Hello. Do you notice the difference? I came back a little bit later to record this. However, I'm here and I want to try and get this done now. So this is being recorded and it is a walkthrough of a foundation WJEC paper. Now, for those who aren't aware, WJEC is the Welsh Joint Education Committee, and foundation goes up to a grade D here. So it's not, so there are questions on there that aren't, sorry, shall I say, foundation in, say, England would have some harder questions in. Okay, so this is up to a grade D. It's last year's paper, and it is, I got it from Maths DIY. I don't know how the solutions and stuff aren't online, but this one is there. And it is a calculator paper. So very, very much make sure you have a calculator with you. Ideally, a calculator that has things like your fraction button on and what have you. I am going to be recording a little workshop on calculator use at some point soon, but I'm not going to make too many promises because, yeah, that's what I do, and I end up I get annoyed with myself for not doing it. Right, so here we go then. So question number 3, write down the special name for each of the following shapes. Now, okay, so we've got 4-sided shape. And here we've got a 4-sided shape. Now, 4-sided shape generally is called a quadrilateral. Think quad bike 4. But this one is, so those 2 lines there mean they're the same length as each other. And these lines here mean that they are the same length as each other, but not necessarily the same length as these. Okay, but they won't be. Okay, so this one is a kite, and I'll put that one in. Some of these things I will write down, and if you've watched any of my videos before, I've realised that when I take the nib off the pad, it's a Wacom tablet, it then kind of jumps somewhere. So I'm starting to use more of a kind of a joined up writing type thing. This one, right, something very similar to this one, because you've got these arrows now. So instead of straight lines, you've got these sort of double arrows. So this one's the single arrow, means that those 2 lengths are the same in terms of they're being parallel. Sorry, I was going to say something else then. I'm like, what am I saying? Yep, those 2 lines there are parallel to each other. That means the gap between them is exactly the same all along. And this pair of sides are parallel to each other, but not parallel to those. But also, they are a different length. So if these sides here were the same length as those sides, this would be a rhombus, but it isn't. So this one is a parallelogram. Now I'm just going to get on here now. For some reason I can't seem to, whenever I put myself on here, it keeps jumping around. There's probably something to do. So if you're watching this and you're like, oh yeah, I know what to do, you know what to do to change it. Parallel, hang on a minute, I'm just going to write that down. P-A-R-R-A, that's it, the 2 L's there. Parallelogram, there we go. It's because it keeps jumping around. Now, obviously, on the paper, don't write in that examiner area. The reason, I just wanted to mention that because someone said to me, what happens if I write in the examiner area? Well, what happens is these papers get scanned in, and they are then available for whoever to actually view them online and mark them. So, I mean, I'm an examiner. I am going to be getting about, I think I've got a quota of about 400 maths exam papers to mark. One of the papers that's going to be sat on next Wednesday, actually. So you have a certain area to mark in. So yeah, make sure that if you're going to write anything, it goes in there. Something says saved offline area. I'm not sure what that one was. Okay, right. Right, 3D shape. 3D means it's a solid shape, okay? So think of a 2D shape would be like a square, a circle. It is a flat. And 2D means 2 dimensions. So generally you've got a length and a width, a base and a height, yeah? With 3D, there will be a height, there will be a width, and there will be a depth, which obviously a 3D shape a 2D shape wouldn't necessarily have. Okay, you can draw a 2D version of a 3D shape, you know, using I don't know what's happened to my words. I think the rain washed them away. What was it called? This certain paper you use. I can't think what it's called now. Anyway, I'll pop it in later. So anyway, this one is a sphere. So SPH. I know I'm doing this for a young lady who is going to be doing this in Welsh anyway, but if you're watching this for English, obviously sphere. All right, so write down the first 4 multiples of 48. Now, remember, you have a calculator. So multiple means we multiply that number, okay? So a multiple of 48, right? So your first one is going to be 1 times 48. The next one is going to be 2 times 48. I just happen to know that. The next one's 3 times 48, 120, 144. Now, note, I'm doing that because I've been doing this for many, 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 many years, and I can kind of do calculations generally quite quick in my head. However, please, you will go 3 times, oops, I've got it in log mode. Right, 3 times 48 equals 144. 4 times 48 equals 192. There we go. So that's all you're going to do. What other number is like multiple that often gets mixed up with multiple? Factor. So if I said to you, what were the factors of 48? Well, the factors of 48 are the numbers that multiply to give it. So 1 times 48 makes 48. 2 is the next one. Well, 2 is an even number. It ends in 0, 2, 4, 6, or 8. So 2 is a factor, and 2 lots of 24. I know this isn't asked on this question. I'm doing this because obviously making sure that I'm trying to cover as much as I can on this question. 3 is a factor. It's 16, I'm pretty sure. Yeah, but if you're not sure, you could do 48 divided by 3. You get a whole number. So therefore 3 is a factor and 16 is the other number. Okay, I'm going to carry on over here. So 4 is definitely a factor. So again, 48 divided by 4, you get a whole number. That's the multiple that you multiply by 4. Number you multiply by 4 to get 48, and it's 12. So I can do down there 5, 6 is 1, 5 isn't 1. How do we know? Because that number is not 0 or 5 at the end, okay? 6 lots of 8, and then you're going to get here 7. 7 isn't a factor. 8 is 1, but we've already got it on this side, so then we stop because all the other factors are here, okay? So those are the factors of 48. Anyway, let's move on. So circle the prime number below. Prime number. It has 2 factors, 1 and itself. Those 2 factors must be different, okay? So for example, what are the factors of 4? Well, I've got 1 and 4. I've also got 2 times 2. Yeah, it's an even number. So it's got 2 as well. 3, so all the even numbers. So it's definitely, I'll go through that and I'll be going, well, it's not that, it's not that, it's not that one. 9, well, I've got 1, 9, and then I've got 3 times 3. So cat's having a bit of a hissy fit there. I don't know if that's inside or outside. That's not 1. 3 is. Now, is number 1 a prime factor? Sorry, not a prime factor. Is number 1 a prime number? No. It only has 1 factor, which is itself. So 1 times 1, yes, that's 2 numbers that multiply to give 1, but they're not different. They need to be different for it to be a prime number. Right, a number has exactly 4 factors. Its factors are 1, 3, 13, and the number itself. What is the number? Okay, so 1 times 13. Okay, well, 13 is a prime number. I've got 3. Okay, so what's 3 times 13 is 39. So is it 1, 39, 2, 3, 13? Maybe. With questions like this, obviously, me going into a lot of detail about that specific question, I try not to in revision sessions when we're getting close to an exam. So it's exact for this sort of question, it's got to be 1 times some other number. So when you have your factors, you've got 1 times the number itself, yeah? Now it says, and the number itself. So we don't know what that number is. But we also know that there is 3 as a factor and 13. So that's leading me to, well, there's only 1 other factor. So 3 times 13 is 39. So therefore, the only other number this can be is 39. It's a bit of a problem solving type thing. So, okay, so what do I know? What must happen for this situation to happen? So you've got 1 and the number itself, and then you've got the other 2. So those 2 multiply to give the number 39. Okay, right. Number 5. Elaine writes down 2 square numbers. First question for you now is, what is a square number? Okay, so a square number is when you multiply a number by itself. So 1 squared would be 1 times 1. Okay, and you've got your calculator. So 1 times 1, 2 times 2, 3 times 3, a million times a million. Okay, and again, at this point, it's a calculator paper. So you could kind of think, right, what are the numbers? And I can write down a few of them here. 3, 4 squared, 5 squared, 6 squared. And again, don't worry too much about the fact that I'm doing them quite quickly. Got a calculator, yeah. So she subtracts the smaller square number from the larger square number. Her answer is 9. Which 2 square numbers did she write down? Now, this is where it's really helpful to actually write some down. Because if you're trying to think these things through in your head and you're trying to think, oh, what could it be? It's you know, especially when we're in an exam, that kind of process can be quite difficult. So we write some square numbers down. And then we think, okay, so which ones of those have got a difference of 9? Well, 4 to 9 is 5. She could, let's look, 16 and 25. Well, 16 plus 9, and I'd literally just do 4 plus 9 is 13. I'm going to share with you another little trick. So we've got something, take away something is equal to 9. Okay, so that means that, and I'm going to call this A, number A, and that's number B. So I'm going to say, well, actually, that first number is equal to 9 plus A. I was going to do A, actually. So B. So that number there, oh, actually, no, ignore me. I know what I was going to do. I'm not going to record. I'm going to keep this in anyway. I know. I'm trying to think of a way to kind of illustrate it in the best way that I can to help you. So this one here is just sort of looking at the difference between the 2 numbers. So I'm going to give you an example. So 25, take away 16. Well, that answer is 9. Work it out, 9. So have your list of numbers, just look at them and say, well, yeah, what's such a difference between them is 9. Well, that's nearly 10, isn't it? So which 2 numbers have got a difference of almost 9? 25 and 36 is sort of almost, but it's not, it's 11. Okay, so the answers are 25 and 16. And again, even though I do these things quite quickly in my head, I always check still. Yeah, 9. All right, Dylan adds 2 odd numbers together and get an answer of 37. Could he be correct? Okay, well, what are odd numbers? Okay, so I would, at this point, I'd be saying, well, write some odd numbers down. So let's just say we've got 1, 3, 5, 7, Let's just say 31. 31. Well, if I have an odd number and I add another odd number together, what happens? Well, 5 plus 7 is 12. Let's just say I had 31. Well, what number would I have to get 37? I'd have to add 6, wouldn't I? Is 6 an odd number? No. To get an answer of an odd number, you would need to add together an even number and an odd number. Okay, so to get 3, you'd have to add, say, 2 plus 1. 7, 5 plus 2. Yeah, so could it be correct? No, because adding an even number, adding 2 odd numbers would give, adding 2 odd numbers, I'm just going to do this quite quickly, no odd numbers gives an even number. I'm just doing it shorthand there. Obviously, use better English when you're doing that. Okay. All right, number 6. What is the special name given to the perimeter of a circle? Straight answer, it's the circumference. Okay. Now, what I'm going to do now is I'm just going to go through all the other words on there because, you know, who knows, they could come up. So, diameter. Your diameter is, and I'm just going to draw a little picture. It's a circle. I promise you, it's a sketch. Center of the circle. So the diameter is the one that goes right across the middle, okay? The radius is half of the diameter. So there you go. So it's like your spokes. So imagine you've got your center of your wheel and your radius is the ones that go out from the center out, okay? Or little spokes all the way around. Your chord is, it's like the diameter, except that the diameter is the only chord that goes through the center. Okay, so a chord is a straight line that goes from one part of the circle to another, but it's not necessarily the diameter. A tangent is another straight line, and that goes outside the circle and it touches. Now, note on there we go. I'll put a little knot there. Obviously, I'm just sketching this. Your tangent is a line that goes outside the circle and it touches at one point. It's funny doing this because at the moment I am doing some work with a student who's doing higher level and we're talking about equations of lines, equations of circles and things. And then I'm also doing some work with an A-level student who's coming towards the end of year 12. And we're doing quite a lot of work around tangents and equations and lots of things. So it's like, if you could see what comes up in maths when you go beyond foundation, it's fascinating, the relationships between lines and circles and shapes and things. And I think quite often that gets missed from the curriculum. And I think for a lot of people, especially those doing foundation level, that would add so much to your experience of maths. But anyway, I digress. I think I might go on to I might do a story on that shortly. Right, anyway, let's back onto this. So one of the following angles is a reflex angle. Da-na-na-na, the reflex, da-na-na-na. I always do that. If you're watching this, the person I'm recording this for, ask your mum what she thinks about when she hears the word reflex. Anyway, I'm going to go on. So one of the following angles is a reflex angle. Which one is it? All right, different types of angles. We have acute. Always think about acute as small. So acute is between 0 and 90 degrees. And what I'm going to do now, I'm going to get 2 pens. This is how I illustrate angles. So angles are, when you're rotating, it's the amount of rotation of one line from the other. Okay, so you always think about something turning. Think of a clock. Just bear with me a second. So an analog clock. Yeah, you've got a turn. So literally imagine at midday, they're both together and then one moves and it rotates around, yeah? And the angle is measuring how much of that rotation. So you've got anything up to that point is acute. Then you've got 90 degrees, which is a right angle. Then it carries on. Obviously, I've got to swap my hands around, and it's an obtuse angle until it gets to 180, or perhaps like that. Yeah, it doesn't matter whether the lines are like that or like that. The angle's still the same, okay? And then it goes further, and so we end up getting a much bigger angle, and that is a reflex angle. So a reflex angle is the one above 180, but less than 360. So that one there, okay? So that one is acute. That one is obtuse. These two here, well, actually, that's 10 more than a full turn. So in theory, when you go on to do like A-level, we then start to look at those angles. And so it's like a full turn, but then actually it's the same as having 10 degrees. But anyway, I'm not going to get into too much detail on that point now. Right, C, the diagram below shows two angles on a straight line. The larger angle is 30 degrees greater than the smaller angle. Find the size of each angle. And I'm going to make a very big point here. I did that with my mouse, so apologies for the circle. Yeah, it's not drawn to scale. So do not get your protractor and try and measure it. Well, you can, I suppose, nothing's stopping you, but you won't get the correct answer. So you're in an exam and you're like, okay, so how could I do this? So you know that it's a straight line. What do you know about angles on a straight line? So that angle there goes all the way around to there, doesn't it? You've got one, and then it's got a line in the middle, and then it's got another angle. I always say when you've got a straight line and it goes change that kind of shape, it's a 180 degrees. Now, what we could do is we could say, well, I've got, say, 60, and then if I add 30 onto that, I'd get 90. Would that work? No, that doesn't make 180. So maybe I could do, say 60, I could do 75. And maybe I could add 30 onto that. So 105. Oh, what have I got now? Oh, not quite enough. So you could just play around with, I'm just going to put the eraser on there. I'm just going to take rid of these. Okay, but if you're doing that and you're trying to work out some numbers, you know, by all means do it. So start off with, say, 70. And if I add 100, that's not going to work. So if I was to do 65 and then I add 65 plus 30 is 95. So if I were to, let me put this pen back on. If I were to put, say, I'm going to put it under here, 65 degrees, and then I've got 95 degrees. Does that work? Well, 65 plus 95 is 160. Okay, no, not yet. What about 85 then? Okay, 85 plus 30 is 115. Okay. Is that going to work? No. So 85 plus 115, that gives me out. It's not going to work. Play around with some numbers. Now, I'm just going to do something now, which I'll show you in a second. 180 minus 30 is equal to 150. 150 divided by 2 is 75. 75 plus 105. I don't know why I didn't ask that. 105 plus 75 is 180. Was there a combination I done whether I did or not, actually? Thinking back on that. Okay. Now, play around. You will get two numbers. It's 75 and then 105. I don't know whether I did that a minute ago. I don't know. Anyway, check your numbers as you're going along. All right. Now, what I'm going to do is I'm going to show you another skill. Okay, so we know, I mean, I can tell you now it's 75 and hang on, I'm trying to get it up. It keeps moving. 75 degrees, and then the other one will be 30 more, 105. They both add to 180, so that's good. Now, what we can do is we can say, actually, this angle here, I don't know what number it is, say. Obviously, I've now done it. So if it's something we don't know, we can call it X, give it a letter. Okay, because that's what we use letters for in maths. It's something that we don't know. But what do we know about it? we know that when we have this angle here and we add another angle to it, which is 30 more, so that means x plus 30. So that's the one angle. That's that angle. And then this one is the angle. Yeah, so it's 30 more than the other one. You see? Well, what do we know about it? We know they add to 180. Okay. So what have I got here then? So that would probably give me 1 mark. So I can say I've got x and an x. That's 2x. And I've got a 30. Always make sure that you don't combine your letters and your numbers sort of to say, oh, that's 2. So that's 2 lots of x, 2 lots of the angle we don't know, plus 30. Now 30 is a number in its own right, okay? And then we know those 2 equal 180. Now, when we solve equations, this is the thing we want, the x. So we kind of strip everything else away bit by bit. And we want to get rid of this plus 30. Now, what's the opposite of adding 30? It's subtracting 30. So we're kind of backtracking what we did to start with to find what x is. So we're now saying we know the and answer is 180. So I'm now going to strip back. I'm going to say, well, let's take 30 off. So I'm left with 2x. That's what I'm left with at that stage. And the answer we had was 150. Okay. And then we have 2 of this angle is 150. So to go backwards, I divide by 2. Okay. Back by 2. I'm just going to put that in there. I think my dinner might be ready, so I'm going to stop now. So x is equal to 75. Okay. Now, that is a very, very quick way of doing like a 2-step equation. You don't have to do that. You could just get your calculator and think, okay, so I'm going to try one number, 60, add 30 to it, so I get 90. 60 plus 90, that's 150, doesn't work, okay? So what I'm going to do is I'm going to try a different number, yeah? I'm just going to double check something. Is there anything? Okay. So I'm just going to carry on that because obviously I'm having my dinner cooked at the moment. Right then, next one. Describe in words the rule for continuing the sequence below. In words, okay? So it's not just like add something or other. So what we're going to do is say, well, what happens to go from there to there? Well, it's getting smaller. So we've taken away 79. If I take 65 away, so if I do, I'm just going to show you this little trick now. So if I do 79, take away 65, I get an answer of 14. So I've got 14, and then it's like, well, that's the number that's been taken off. So 79, take away 14 is 65. Okay, so that's just a little trick. So those are the 2 numbers we know. The difference between them is what was taken off. So, and with a sequence, you will see that that's the same number each time. Okay, on these kind of sequences. So we're going to say describe in words, and it's subtract or take away 14. Okay, subtract 14, and I'm just going to put that on there, 14. But it says 14 in words, so I'm going to put FOUR. It keeps moving. I need to change the settings on that again. Okay. Give it a bit of a clean. Right, write down the next term in the sequence. Right, well, a sequence, we just carry on the pattern. So I'm looking at these and I can see the gap between them is getting bigger each time. So I'm kind of thinking, well, is it times by 2? Did you times that by 2? Multiply that by 2 to get that. So let's have a look. 46 times 2 is 92. Okay. I'm now going to try that again. So I'm going to do 92 times 2, 184. That's the one. So just try it. Remember, you've got your calculator. So, well, 368, I'm going to carry that on, times 2 is 736. There we go. Okay. Right, so let's further down there. So Adrian has N grapes. He eats 4 of them. Num num. Write down in terms of N, the total number of grapes Adrian now has. So what should we say? So I'm just saying 9. Okay, I'm just going to say. So I'm just conversing with Matt about what time my tea's on. Right, okay. So Adrian has N grapes. He eats 4 of them. How many does he have? He's got N. For a lot of people at this point, it's like, well, I don't know how many he's got. No, we don't know in terms of an actual number, but it's just a number we don't know. Yeah, we're just saying we don't know what that number is, but we're representing it by a letter. So whatever that number is, so let's say it was 20, right? We don't know what it is, doesn't matter. But let's just say it's 20. And if it eats 4 of them, what happens to that number? Now, some might say, well, it's 16. Okay, good. You know, that's nice to have. However, what I'm interested in, and this is where a lot of rules in algebra come from, really, is that I want to know what you did to get that 16. What method did you use? Because we use exactly the same method with the numbers and the letters, okay? So we took away 4, okay? Let's do another one. So I'm just going to erase that again. So I'm going to use that with my mouse. Let's just say we had, it's just, put that one on. Let's just say I had 100. Okay, so if I have 100, what do I do to it? I take 4 away, okay? So therefore, if I've got whatever that number is, could be any number, what do I do to it to say how many is left? I take away 4. That is it, okay? And sometimes it says write down in terms of N. You're like, well, what does that mean? When it says in terms of, it means that it's going to have something with N in it. Okay, sometimes we have answers that say in terms of pi, you know, the pi symbol. That just means that there's going to be pi in the answer. We don't have to like work out, press the button on here to get it. All right. Right then, let's move on. Question number 8. So complete the table below so that each row will show equivalent fractions, decimals, and percentages. The first row has been completed for you. Just reminded me, I'm actually going to be doing a few little free webinars on LinkedIn coming up soon. And one of them, first one I'm going to be doing is fractions and decimals and percentages, because it's one of those areas where a lot of people get really nervous about. So if you know anyone, let them know. Anyway, it's just a way to get mathematics known in this sort of corporate training land. So 1/4 is 0.25 is 25%. Now, what I want to do is highlight something to you. See here, we've got 1 under a line and then 4. What does that line actually really mean? Have you ever thought about what that line means? Because actually, that line means divide by. Because if you get your calculator now and you test out, so 1 divided by 4, what do you get? Now, you might get 1/4, yeah? But if you click on your S to D button, which is there, if you've not got one of those, I'd highly recommend getting a calculator that does. You don't have to spend a lot of money, to be honest with you, to get one. I've got a few different ones, actually, I'm happy to lend out, okay? But you get 0.25. Now, 25% means, and I'm going to write this in a different way, 25 out of 100, okay? And now I'm just giving you this to sort of give you some other extra bits as well. 0.25 means, so to turn that into a percentage, we just multiply it by 100. So to go from there to there, we just times by 100. So and again, I'm giving you this because, again, I'm trying to give you a big picture of all the maths that potentially could come up, yeah? And fraction to a decimal, we just do the numerator divided by the denominator. So 7/10. So this would be 7 divided by 10. Okay. You've got your calculator. If it wasn't a calculator paper, I would be doing this. So 7 divided by 10. Okay. And then we do have a little couple of things there, and I would say 0.7, and it would end up being 0.7. There's a video on that on YouTube where I show how to do that. Okay, but this is a calculator paper I'm doing this for. So yeah, 7 divided by 10 would give you 0.7. And then to go from a decimal to a percentage, I multiply by 100, which is 70. Okay. Also, just a little tip, right? You've got, say, hundreds, tens, and units. Okay, when you divide by 10, let's just say we had 700. If I divide that by 10, I move 1 unit that way. So I go 1 place that way. So I end up with 70. Just a little bit of a little sneaky thing there. All right. You know what? I think the better you get at maths, I'm going to tell you a secret. You just learn more tricks. It really is. It's about learning more tricks, about recognizing things that you can think, oh yeah, if I just adapt that slightly, that means I can use that trick. I can use that trick, or I can use that trick. And it's quite often it's not taught like that. Anyway, so I can't save the world altogether, but I can do a little bit towards my bit with maths. Anyway, so it says here, find the square root. That's what this sign is here. It's like a tick with a lid, isn't it? So we've got the square root. So on my calculator, I'm just going to click on the square root. I'm going to do 11.56 equals. And then I'm going to say plus 2.5, and I'm going to press the square button, which is the button that looks like this. You'll have an X and a square. That just means put X there because it means whatever number you've got squared. Okay, that's it. So get an answer. You should have an answer of, and it doesn't specify how it wants the answer. It wants 9.65. There you go. So just put the numbers in, get your answer out. In theory, I mean, I had 193/20 on my calculator. So if you got that, there's no reason why you couldn't put that. It doesn't specify it has to be a decimal or whatever. So either of those. Prefer that one, be more preferable. However, if you did that, you should get the marks, I would have thought. All right. Next question is, use the formula W equals 7x plus 2y to find the value when x is 35 and y is 29. So remember back when, I'm just going to see if I've got a drink in here. I was going to get water. Have I got anything in there? Not a little bit of drink in here. Keep me going for the last couple of questions. So what it means is there's something called W. It could be whatever. It could be a rule that works out how much your bill costs, yeah, for your mobile phone or whatever, yeah. You have 7 of them, you've had 7 of those, and you've had 2 of those. So what is the total cost? Okay. So what I'm going to do here is I'm just going to couple little reminders for you. There's 2 marks. Your first mark will be to show that you know how to substitute in those numbers. Now 7x means 7 times x. Now it's told us that in this particular case, x is equal to 35. So we're saying it's 7 times 35. What else is the rule asking us to do? It's saying add, so I'm going to add 2y, which means 2 lots of y. So that's what I mean, that x there, it's times 2 lots of, okay? So that would give me 1 mark. I've shown the examiner, I know what it means to substitute. The next mark will be for doing actually doing that calculation correctly. So 7 times 4, 7 times 35 is 245. And I'm going to add to that 2 times 29, which is 50, 60, 70, 40, 58. So the end answer is 303. Now, I'm on this, I'm doing this, and if you're watching this, you're probably very aware that I have got a lot of, I suppose, letters after my name. for maths, a lot of experience, a lot of worked in maths pretty much all my life, or some kind of numeric with its training, corporate training, teaching as a statistician, talking to clients all around Europe and what have you. However, if I don't concentrate, I make avoidable errors. And I will always be very honest about that. Now, it's one of those things, when you like have an interview for something and, you say, oh yeah, I'm really accurate and blah, blah, blah. I will admit I miss things if I don't concentrate. But what I am very good at is making sure that I've checked my answer. Okay, so when I go back, sometimes I can do something and I'm working down and I know the rules and I know what we have to do this, that and everything else. And then I get to the answer, I'm thinking, that shouldn't be, that should be something. And I guess my experience allows me to be able to do that much easier. So here, I'm actually going to just double check that. So 7 times 35 is 245. 2 times 29 is 58. And then 245 plus 58 equals 303. Double check your answers. So yes, calculators are great, but make sure you've clicked the right buttons. It's so easy to click on the wrong one, but also write down what you're going to work out first before you pick it up. I see a lot of students, they're like a question and it's like, yeah, you are doing two things. You're illustrating that you know what that means. So put that into there. So you're showing the examiner you know how to do that. Okay. And then obviously, then you can use the calculator correctly. Right. Now, WJC have some questions where they talk about organization, communication, and accuracy. So when you, as an example, when you use maths in real life, because believe it or not, maths does exist outside the classroom. An example is a job I did for many years as a senior statistician. And you would have to analyze, you might have like thousands of responses about something. And then you have to kind of summarize it and write a report. And sometimes you have to explain where those numbers have come from. So what this is doing is kind of almost like preparing you for the element of using numbers and explaining what you're doing. So Geraint writes down 3 different even numbers. The smallest number is 3/5 of 200. The range of his numbers is 4. Which 3 different even numbers did Geraint write down? Okay, so the first one is I'm gonna write down here. So I'm looking at this and I'm thinking even numbers. Right, well, I could have 2, I could have 4, 6. There's loads, isn't there? So, but I've actually been told one of them is 3/5 of 200. So I'm actually going to say here, I am going to work out 3/5 of, let's have a look. Hello, somebody's walking in here as I'm recording. Who is it?
I got 13 chicken nuggets in the 12 bag.
Did you? Harris got 13 chicken nuggets and the 12. Aye, your nose. Very good, nice. You want me to count? Yeah, this is the chicken nuggets who's coming now. This is live. I'm recording this for somebody you go to hack with. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hang on a minute. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13. I've counted 14.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 in there. Wow. Anyway, I'm going to go back to this. I'm in the middle of recording, sweetheart. All right, okay. She's got 14 chicken nuggets and 12. Hey, that's chicken dinner, that is. I am going to work out the smallest number. I'm going to work out, I'll write this down. So I'm going to say it out loud. So I am going to work out the first number. So using my calculator, I'm going to do 3. So when we work out 3/5 of a number, we're saying, well, 200. Well, we can do the calculator button. So 3/5 times by 200. And that's 120. So I'm going to work out, and it takes me a while to do this. So I'm going to try and do it, work out. So this number here is 120. So I'm going to talk through what I'm going to say as opposed to, because the writing on this is not working at its best today. The range of his numbers is 4. So the range is the biggest number, take away the smallest number. So the next thing I'd say is, to find the biggest number, I would add 120 to, add 4 to this number to get the biggest number, because the range is 4. So Carol's coming in, it's completely thrown me. So we've got 120, and then we've got 124. And then let's have a look at the question. It says he's got 3 different even numbers. So this is the smallest, this is the biggest or largest. So this one must be 122. Okay, so all you're doing really is just explaining what you've done. So again, out loud, I would say, I am going to work out the smallest number. This is 3/5 of 200. This is equal to 120. As the range is the biggest number, take away the smallest number, the range, the biggest number must be 124. And then because Geraint has 3 different even numbers, the middle number must be 122, because that's the only even number between those 2 numbers there. Okay, that's it. You're just sort of explaining what you've done, and you kind of organised it. I will probably write something down. Printer's not in the best shape at the minute. It does work. It's just not connecting to the Wi-Fi. I've got to sort that out, work out what's going on. Anyway, okay, so question number 12 then. I've not got the whole question on there. So we have a coordinate grid, and I call this coordinate. So you've got your X along the bottom, the horizontal, and Y along the top. So just as a bit of a recap about this, if I said I wanted the coordinate, say 4, 5, I would go along X to 4, and then I would go up or down until I get to 5, which is 5 is up there. So that one there would be 4. Is it going to let me put it in? Look. Not picking up my oh. Do you know what? It does help if I use the correct end. So I'm just holding it. There we go. So 5, 4, 4, 5, sorry. There you go. So B is the midpoint of line AC. Find the coordinates of C. Now, when it says AC, basically that means, and I'm just going to kind of illustrate it here, you're going to have a point called A, and then you're going to have a point called C, and it is the line. And in fact, I can do a line on here. So I keep reminding myself, it's like, I can't even see it at the moment. Is it that one? So we would do a line between the 2. Okay, and that's it. So let me just go back onto there. There we go. And go back onto what I was doing there. So we have got a line, and I'm going to put this down, put another line in again, that goes between there and there, because that's the middle, isn't it? So we've just got to carry on in the same direction for as long as I've already had so far. So by that I mean going from A to B, I've gone across diagonal 2 squares. So the line, remember, it's a straight line, so it's just going to carry on in that direction, and it's going to be again across 2 squares, because B is the midpoint. When you're doing this in an exam, get your pencil and a ruler and just sort of try something out. You think, well, it's got to carry on down there, so I need it to be as long as the first bit. Okay, so keeping myself hydrated, very important. So therefore, let me put on the pen here. So this here has got to be C. So the coordinates of C are, remember the X one first, because X is before Y in the alphabet. Good way to remember it. It's 1, 1. And the way we would write that is, let me see if they put anything in. Oh, they have. So they put the brackets in, and you're just going to put 1, 1 there. Okay. Right, A and B are two vertices of a right-angled triangle. So when I see that, I'm going to be going right, I'm going to be going right, there, that's a right-angle triangle. Okay. Point D is to be plotted on the grid so that the triangle ABD is a right-angle triangle. The coordinate of D is negative, the x-coordinate. So let's think, well, that's the x-coordinate, the positive, but the negative. So it's going to be somewhere on this side, yeah? Give the coordinates of a possible position of point D. So let's just remind ourselves again. We've got A, B, and there's going to be another point D, so that it's a right angle triangle. So I'm kind of thinking, I would get my pen and my ruler and I would start drawing some stuff. So I just need to move my mouse slightly here. So I'm going to do insert line. Click on, is it going to give me a line? Sorry, it's just, if you could see, I've literally got, you won't be able to see this, but I have, when I'm in Zoom, because I'm recording this in Zoom, I've got my menu above that says you are screen sharing. It's also got a menu above that for Zoom. And then I've got my menu for on here, and that was actually covered by the other one. So here we are, I'm going to draw a line. So it's just sort of playing around with the ruler. And so we could say, well, the end D is going to be at the end of this line where I'm kind of wobbling it around. But they said that the x coordinate has to be negative. Well, here it's like 1, here it's 2. So I'm going to send it right over there, but I've got to make sure it's a right angle. So actually, that would be all right. Or I could do that, couldn't I? Because both of those, it's leaving me. Let me put it there. So both of those, that gives me a right angle between the angle between that and that. And the x coordinate here is -2. Okay, so always look down or up to see where what the x coordinate is, and then you're looking left and right to find out. Although that could be a bit confusing actually saying it like that, but yeah, when you're looking here, whenever your point is, you're going to be looking down to see where the x coordinate is, or from here. So the x coordinate for this is down to get the 5. To get the y coordinate, you look to the left, obviously the right, if it's somewhere over here. Okay, so here the coordinate is -2 and 7. Okay, now I remember doing something like this. There was a question on an exam I was marking last year for AQA, and you had to get coordinates right, and it was a foundation level exam, which took, I think it was up to grade C, I think possibly grade 4 or 5, and but the level of people, the number of people who struggled to get a graph and coordinates was quite high actually. So let's go, it was going to be -2 and it was 7, I think, wasn't it? Let me just double check. So I've got -2 and I've got 7 there. Okay, all right, so again, oh yeah, 6 marks. So what does that mean? Actually, that I like, no pun intended, the mean. 6 marks means there are 6 things you potentially have marks for. Okay, so you can still only do say two bits, you get 2 marks. So even if you didn't answer the whole thing, doesn't matter. Obviously, the aim is to do as many as you can. So expressing all the amounts in litres, calculate the mean of the 3 amounts. So litres, so that one's already in litres, isn't it? What about this one? Well, that's in millilitres. So what do we know about millilitres and litres? Well, I know that, I'm just going to kind of write this over here. I know that 1,000 millilitres is equal to 1 litre. Is 1 litre. And I'm sort of right, I probably should have done it below there. So 1 litre. I'm just going to put a little, when you've got 2 lines together like that, I always tend to put the 1 with the little thing on the top. So here I've got 1,615 millilitres. So what I'm going to do, I'm going to divide that number by 1000. Now I'm doing exactly what I said to you to not do, isn't it? So I'm going to say I'm going to do 1615 divided by 1000 to give me how many litres. So I'm going to show that I know how to do that. Then I'm going to do it on the calculator, and then I'm going to put my number on it, which is 1.615. I don't know why I just automatically looked at the calculator then, even though I can do that by sight. So that's 1.5 litres. Okay, so we've got 1.25. I've been asked to work out the mean. So if I work out the mean, I've got to add them all together. So I've got that number there. And then I've got the middle number to go over now. So when I've got that, I then have to divide that by 3. But that's okay. So 2.73 pints. Now, I'm trying to remember what the conversion is now. Litres to pints. So litres, so 1 pint is 568 millilitres is equal to 1 pint, I think. I have a feeling it is. I'm going to, Alexa, how many pints are there in a litre?
1 litre is about 1.8 imperial pints.
Okay, so 1 litre is equal to 1.8 pints. Well, if that's the one then now, so if I've got 5.68 meter from 5.6, 568 times 2 equals 1 point, yeah, roughly. So it's 1.8 pints. I thought I couldn't remember what the number was actually for the conversion for some reason. Alexa, what is 2.73 pints in litres?
2.73 imperial pints is about 1.551 litres.
That's about 1.51 litres. So I'm going to do 2.73 divided by 1.8. I get 1.51, yeah. So 1 litre is 1.8 pints. So that's 1.5 and 1.516 litres. So we have, I'm just going to put that number in here. So we've got 1.516. I wouldn't normally put myself, if I couldn't remember something, it's like, I can't, I look it up. So I've got to remember that conversion. Okay, so let's add these three numbers together. So 1.25 plus 1.615 plus 1.516 equals, and I have a number of, so looking on there, 4.381. Keeps moving, 4.381. There we go. I'm wondering if it's because, I know what it is. I do something and then I click on the little buttons on the pen. Okay, so 400, so find the mean. I'm going to be doing, sorry, I forgot I'm kind of talking on here now. So the mean is equal to, 4.381. So I'm going to tell them what I'm going to tell. I'm going to tell it what I want to do. And then I need to divide that number by 3. Now, if I've done that calculation, you've got a Casio calculator. You have a button on the bottom right-hand corner, on the bottom right, it says ANS. Okay, so I've cleared my screen. And what I'm going to do is I'm going to click on answer. So ANS equals, it brings up the last answer that you had. Very, very useful. If you're doing a calculation and you've got to do another calculation with that number later, you bring it up again using answer, because then you've got the full accuracy of the number. So for example, here we had 4.381. Do not round it up. Keep it totally as 4.381, and then keep it stored in your calculator, and then divide that number by 3, and you will get a number of, let's have a look. I'm just going to put this down here. Look at it. I'm literally right. I'm going to move that up actually now. It's right at the bottom of where I'm writing on the end of the table. So it's equal to, the mean is equal to 1 point, and is it asking me for accuracy? Calculate the mean. Oh, okay. I didn't scroll down there. Okay, so 2.5 is equal to 2.73, 1.516. Now, obviously, if you'd had that paper in front of you, you would have seen this at the bottom. So 2.73, I'll keep this jumping up. 1.65, 1.615. Oh no, that was that one, 1.615. I'm looking at that thinking that doesn't make sense. 1.615. Again, does it make sense? And then I'm just going to get the eraser at the top. I'm going to move that. And just a little thing as I'm doing this now, obviously remember in your exam, you're supposed to use a pen, okay? Because you want to make sure that none of your answers potentially could be rubbed off. So make sure you use a pen. Maybe if you want to do it to start with and you're not sure or something, just have a little go in small and just sort of have a play around. But make sure that your answers are done in pen. Unless there is I'll say that, I don't know if there are any special accommodations for using a pencil. I think it would probably be typed up maybe, or you'd have a scribe. Anyway, so 2.73, that one was where we had 1.516, so 1.516. And then the mean of the amounts was 1 point, and I started, didn't I? And then I hadn't quite finished the number up here. So 1.460. And it doesn't say for accuracy. I would probably do 1.46 litres. Because it's 1.460333333. So I think I'm just going to stick it to 2 decimal places there. Right, let me just have a look at the time. Okay, so I'm just looking at what I'm doing. Okay, I'm just seeing what other questions are, because obviously they're all different topics. Okay, some quite, I like these questions. All right, we've only got 3 more questions left. That's fine, I can do those in that time. So 2 fair spinners are shown in the diagram above. In a game, the 2 spinners are spun. Bit of like a word, tongue twister. The 2 numbers obtained are multiplied together times to get a score. For example, in the diagram above, the score is 6. So you've got 3 times 2 gives 6. So 3 times 2 is that one. Some of the scores are shown below. So this is what we call a sample space diagram. So we've got sample space, we've got 2, 4, 6, 8, the options you can get with 1 spinner, and 1, 3, 5, the option you get with the other one. So whichever combination we have, we can then work out what the multiple of the 2 together is, what the product, another word there, product. So, and what I always tend to do as well, just a little reminder, we're multiplying. You might see when you use the grid method, some of you might be used to using that. So 2 times 1, 2. Remember your calculator. If you're not sure, do them by hand by all means, but double check. It's so easy to just, think, oh yeah, I can do that quickly. I can save myself a bit of time. But just double check. Yeah. 5 8s are 40. There we go. So complete the table to show all the possible scores. There we go. And explain why all the scores are even numbers. Well, any number multiplied by an even number gives an even number. Okay. It's funny because when you do higher level, intermediate, actually more like higher level in England, you get to prove this. And you say for it, why is it that, can you prove that when you multiply any number by an even number, you get an odd number by an even number, you get an even number? The answer is because you get something like 2n and then times by n, which is the n squared. Yeah, don't worry too much about that, but yeah, 2n squared, which is a multiple of 2. So it doesn't matter what it is, it will always be an even number. All right, so actually, I just wanted to say something. Don't worry about this, what I'm doing here. That's, yeah. Excuse me, I'm quite tired. I'm going to get to the end of this paper and then go and have my dinner. So it's literally that. Whenever you multiply an even number by another number, an odd number, you are going to get an even number. Okay. And again, if you're not sure, try things out. Okay. The exam, remember, you've got however long you've got in your exam. So I know we always say about writing things down, But if you're sort of thinking, I'm not quite sure how that goes, but I'm just going to have a go with a calculator and I'm going to, yeah, try something. Do it. Okay. Just try things out. See what happens. What is the probability that a person gets a score of 10 or more? Probability. Now, what is a probability? Well, it's a number between 0 and 1. 0 means it is impossible. 1 means it's certain. Most things in life, there is a probability between 0 and 1. Okay, and it's a fraction. So I know it's on the other page. In fact, I'll put it on so we can see both. Okay, so here when we've got a fraction, we're going to have a fraction. So we're going to have a number on the bottom, and I'm going to just put a little box there. We're going to have that number there, and we're going to have a number here. So that number at the top is, how many scores are there of 10 or more? So I'm going to look in this table and I'm going to see, well, there's 1, 2, 3, 4, 5, 6, 7. So there are 1, 2, 3, 4, 5, 6, 7 numbers that are 10 or more. And then the number on the bottom will be how many options there are altogether. Okay, so that is the numbers in the table. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some people say, well, actually, what if you've got duplication in here? So for example, if we've got a duplicate number, yeah, we've got a 6 and 6. You see, you have 2 opportunities to get 6, a 6 and a 1, or a 3 and a 2. Each of those is as important as each other. So they are 2 separate possibilities, okay? So all we do is just add them all up. So, or count them, sorry. So you've got 3 4s, which is 12. Another little thing there, I added them all up. I went 1, 2, 3, 4, 5, 6, 7. What you can do as well is say we've got 4 along there and 3 down there. So it's 4 lots of 3 or 3 lots of 4, which gives 12. Right, let's have a look now. Players are charged £2.50 to play the game once. And I'm just going to literally write this down. They're going to pay £2.50. Okay. Each player gets a score of 10 or more. They win £3.50. So if they get 10 or more, I'm just going to kind of show this as a little diagram. Okay. Excuse my write down. Or, so that means they win. And if they didn't, they lose. Okay. They have games like this come up sometimes and you're like, well, I don't understand that. So look at the options of what can happen. So you pay £2.50. If you get a score of 10 or more, you win £3.50. You get sort of £3.50. Okay. And if you lose, you just, that's it, your money's gone into the pot to pay for the people who are winning. Now, when people are coming up with games like this, they kind of would balance off like, well, how much chance are we going to give people to win? Because we don't want everyone to win, but we need enough to win to sort of make it appealing to play. Yeah. So it says, how much profit would you expect to make when 228 people play the game once? Profit. What does profit mean? What is it? Well, profit is money in. I would sort of say money in, take away money out. Is the easiest way of explaining it. Okay, so it's money, and I'm going to write that down here. And again, I'm sorry, it's jumping out. Money in, take away money out. So then we're going to think about, well, what are those things? Okay, but don't worry too much. We've kind of said, well, that is what the profit is. Now I'm going to focus on what those numbers are. I know sometimes when we have problems like this, we're like, oh, money in and money out, but what is that amount? I don't know what that is. And then we kind of get into this spiral of, can't do this. Okay, I know what profit is, so I'm going to tell them what profit is. So money in. So we get money by people paying to have a go. So it was £2.50, isn't it? So £2.50. And how many people played? Well, it says 228. So those 228 people will have paid £2.50. So I'm just going to put that there, 228. Okay. And then what will we pay out? Well, there's £3.50, isn't there? So we know that if they win, they pay out £3.50. Okay, so again, we're just trying to think each step at a time what's going on. How many people are going to win? Well, how many people are going to get a score of 10 or more? Oh, well, what is the probability of getting a score of 10 or more? I'm going to go over that again and notice the sort of what's the word, the order, the questions I'm asking and the order they're in. So we're paying out £3.50 for everyone who wins. Well, how does somebody win? They win if they score 10 or more. What is the probability that somebody will score 10 or more? It's that, 7/12. So we are going to have, I'm going to write this down here. So the number of people that win, I'm going to write this down, number of winners, number of winners, excuse me the words, winners, number of win is equal to, oops, write it down first. So 228 times by 7/12. So there's a 7, and this is what we do. It's like our expected number or relative, it's like relative frequency we also look at as well on this same thing. So the expected number of times the expected number of times something would happen would be 7, the probability, 7/12. And then you're going to do times by 228, which gives an answer of 133. So for every 12 people who play, 7 of them are going to win. That's kind of what we're saying. So we're saying, well, how many lots of 12 people are there in this? So 228 divided by 12, which gives 19. So of those, each of those 19, 7 are going to win. So we're going to, each 7, so 17, start again. There's 19 lots of 12. So you can imagine these little groups of 12, group of 12, 12, 12, 12. There's 19 of them. And in each of those 19 groups, 7 will win. So that's where we get the 133 from. So you've got the 19 times 7, 133. So now we've got our number. So it's £3.50 times by, and again, please don't write in that corner on the out-hand side because on the right side, because you might not get your stuff marked. So I'm going to use my calculator because it's there for me. Oops, I've clicked on Google, so Google might come up now. Oh no, it's all right. So I'm going to do 2.5 times 228, which is 570. So we get £5.70 coming in. And then I'm going to take off. So I've got £3.50, 3.5 times by 133. So that gives me that's £465. Now, in my eyes, I sort of think that's actually quite a big amount of money that's going out in prize funds. You know, I remember doing something. It might have been a higher level question where we had to look at the balancing of like, well, if I change those numbers, can I change the score? So can I change, if I change the, I'm just going to go up to here for a second. So if I were to say put different numbers on here, but keep the rule the same, how could I decrease my probability of getting a number of 10 or more? But you've still got to keep them single numbers. So you've got to keep these single numbers as well. It's quite an interesting little project. Anyway, so we've got 570 coming in. We're taking our 465.5, and that gives us an answer of £104.50. So £104.50. Now make sure that you do use, when you write money, it has 2 decimal points. Yeah, because money has it's pence, isn't it? So it's pounds and pence. So make sure that you have got 2 decimal places there. I'm very eagle-eyed when it comes to looking for companies who do not write numbers of money correctly. So you see it in restaurants and it might say 104.5. I'm like, that's not that's not correct currency format. Anyway, I normally name and shame them. I educate them and say, look, I don't know if you're aware, but anyway. All right, last question then. So the length of a rectangle is double its width. Right, okay. So I'm going to draw, at this point now, I'm just going to draw a little rectangle. So I'm going to say, if that's the width, that's 2 times the width. Yeah, just what I've done there. If you're not quite sure of that, it's like, well, I'm just going to say, well, if that's 5, that one's going to be 10, say. Okay, so I'm just illustrating what's going on. The area of the rectangle is greater than 60 centimeters squared. Okay, well, what's the area of a rectangle? The length times the width. So that would be 50. Well, it can't be 5 and 10, can it? Let's have a look. Let's have a look then. So maybe if we had, say, 6, if the length was 6, width was 6, say that was 12. Okay, it's 6 times 12. Right, so I've got my calculator, 6, 12, 72. Okay, that possibly could work. It also says the perimeter of the rectangle is less than 40 centimeters. What's the perimeter of this? 6 plus 12. 6 plus 12 plus 6 plus 12. Or you could say 6 plus 12 times 2. Doesn't matter. As long as you're adding up all the distances on it. So you've got 12 plus 12 is 24, plus 12 plus 6 is 12, which is an answer of 36. Oh, okay. Now again, I'm just going to just double check. 6 plus 6 plus 12 plus 12 is 36. Give a possible width and length of the rectangle. Calculate the area and the perimeter of this rectangle. I've done it. Now it says give a possible width and length. Okay, so here we've just tried, I tried that one. Show all your working. So it's almost like it's not one of those communication questions per se, but it wants you to show you working. So we could say here that the area, where's that 50 come from? Well, it's 5 times 10. 5 times 10, which is equal to 50. And I can just say too small, too small, too small. I don't know why it's jumping around. I need to check that again. Okay, so that's it. You're just thinking, okay, well, I'm going to try that. If I've decided I'm not going to do that one, I'm going to say it's too small, need bigger length. Okay, where did I get that 10 from? So that one was, that's just 2 times 5. Yeah, 2 times 5. Here, it's 2 times 6. So I saw it again, I'd write down 2 times 6. I would also write 6 times 12 to work out the area. And then the perimeter, obviously I've written the perimeter down there, and I would be saying that is the perimeter. Okay, so obviously making things very clear. My actual written work, physical written work with a pen and paper is much neater. So what I'm also going to do, once I've got my printer sorted, in fact, I don't need a printer, do I? I can show you what I would do, written answers there. Now you've got the answers. Oh, we've got another question. Okay, I'm just going to quickly do this because then I am literally going to have my tea. Oh, there's another one. Okay, anyway, so reflect the shape in the line x equals 1. So x equals 1. Well, let's see, where is x? So x is that axis. Where is x equal 1? Well, it's equal 1 here. It's also, oops, I'm going to delete that. That's not meant to show like that. So x equals 1 is basically everywhere. Insert line is everywhere along here. Okay. So that's the x equals 1, and I've got to reflect it. So literally, I am going to be doing that. So we're going to go 1, 2, 3 spaces, and I'm going to go to the other side, 1, 2, 3 spaces the other side. And I'm going to have a shape that is basically like that. I'm then going to have another shape, which is like that. Yeah. Now these would be filled as well. So that's what you've got. So remember, it's almost as if you're going to, I would shade that in as well, is if you were to fold the paper in half, and this is the middle. Let me just get the pen there. That's the middle. I'm kind of rushing a bit because my tea's ready. That's the middle. That's that bit there, not that. Then you fold it together, that's where it would be. So obviously that line there would probably move just a little bit to the right. And the final question, which I think we've got here, 3 marks. A car travels at 129 miles in 3 hours, 30 minutes. Calculate the average speed. Okay, now, average speed, what's the formula? Now, I know a lot of students are good with this because they've learned it in science as well. So speed, now we've got distance divided by, remember that one, distance divided by, it's always D on top, okay? D, and then what we do is we cover off the thing we want, so speed. We want that, so it's distance divided by time. So I'm just going to do speed is equal to, now what I would normally do is I would do the things at the side, and then I would say, well, speed is the thing I'm not sure. Distance is in miles. Miles. Again, don't write on the border. I'm just doing that for this. Time. Now it's got to be in decimal time. So it means 3.5 hours, because here it's talking about miles per hour. So we need to make sure that our time is in hours. So therefore 3.5 as opposed to 3.30, okay? 0.5 of an hour is 30 minutes. So speed is 129.5. And again, we're going to show our working out, divided by, what was it? 3.5. And I'm going to use my calculator. Nice little straightforward calculation at the end. Divided by 3.5 equals 37. And what was the answer? Miles per hour. MBH. And they say, why is it average speed? Well, in that journey, those 3 hours 30 of the 29.5 miles, they will have stopped and started and gone to junctions and, you know, gone faster and slower. So we're saying on average, so we've added up all of the miles and divided by the total amount of hours that they travelled for, which was 3.5. So on average, across those 3.5 hours, they drove at an average speed of 37 miles per hour. Right, that is the end. So, oops, there's a couple of, those are my recordings from before. I don't know whether you see them on my screen. So that's it now. That is, I've gone through the whole of that paper. What I might do is kind of do it in, what I do is import the questions into PowerPoint and kind of do it a bit neater. So, you know, obviously this is a very much rough and ready version with me using this pen on the pad, which just jumps around and things. But hopefully, if you listen to what I've been saying, it's like, oh, yeah, there's a lot of nice little nuggets in there to sort of help you to understand and think about other topics that haven't necessarily appeared on that paper last summer. Now, there is a piece of paper, I'm just going to have a look for it here. It's a very, very tatty piece of paper on my desk. It was where it is, and it's basically all the things that are expected to come up on the paper. I can't see it at the moment, so but I'm going to go and have my lunch now, my tea. So Saturday night, it's 8 o'clock, and I'm going on the sofa and get ready for the 1% Club. So hope that's really helpful, and any questions, just ask me. All right, take care.